Alright, so now we're going to talk a little bit about stellar formation, how stars form. So most stars form in what's called a star-forming region, which, very descriptive name, but it's also sometimes called a stellar nursery, because it's where stars are born, which is kind of a more creative and cute name. Anyway, what they are these very, very large clouds of gas in interstellar space, oftentimes created by some kind of a large supernova blowing gas all over the place from a very large dead star. And anyway, these large clouds of gas will perhaps be able to, under the influence of their gravity, start to collapse and pull themselves together. But they don't pull themselves together into one star. Instead, the cloud of gas is not totally uniform, as you can imagine. It'll have some areas that are denser than other areas. And as the overall cloud collapses, mass will tend to accumulate in those existing denser areas from the beginning. And so those denser areas are where the stars will form as this cloud collapses. And a lot of stars can form this way. Some of these clouds are big enough, oftentimes, to form a few thousand stars, right? These are a big thing. Again, the stars form in these high-density regions. And another interesting feature of this happening, stars like this are called clusters. All the stars that form from one of these clouds collapsing is called a cluster. And one of the interesting qualities of clusters, for reasons I'll get to in the next video, is that the way they're formed kind of means that all of the stars are about the same age in the cluster. They all form at about the same time, which is interesting for reasons, again, I'll get to later. But it doesn't go straight from molecular cloud to stars. Before the stars form, bodies will form of condensing gases and dusts from the clouds, called protostars. And protostars can get very hot, actually, because as a material like gas and dust and stuff falls onto them, when it's further away from them, it had a lot of gravitational potential energy, and then it loses that potential energy as it falls toward the protostar. So the potential energy has to go somewhere. And what it turns into is it turns into the kinetic energy of some kind of heat. The gas heats up, or it is emitted as light, and that hits some more gas somewhere else and heats it up, right? And in any case, the result is that this gas heats up as it falls down, and then it lands on the protostar and heats the protostar up when it touches it, right? But anyway, the point is that even though these protostars can get quite hot and can even shine from how hot they are not real stars, not true stars, because they go from being a protostar to a true star when they become massive and hot enough to create pressures and temperatures in their cores that are enough to start nuclear fusion. And that is the defining quality of a star, nuclear fusion in the core. And so once the protostar begins nuclear fusion, it's not a protostar anymore. Now it's a star. Nuclear fusion of hydrogen, specifically, because that's the easiest to do, and so it's the first that any star is going to attain. Anyway, now, another detail about main sequence stars being what we consider normal stars, of various sizes, but their defining feature being that they're burning hydrogen fuel in their cores. One important feature for of them for this week's assignment that I just want to reiterate is the relationship between mass and main sequence lifetime, and it goes like this. Stars with large mass, they have short lifetimes. And low mass stars, stars with a small amount of mass, they have long lifetimes. The lifetime, the main sequence lifetime of a star is determined by when it runs out of hydrogen fuel to burn for its normal hydrogen fuel burning. And you may think, well, large mass stars would have more fuel, right? So shouldn't they live longer? And they do have more fuel, but due to their larger pressures and temperatures that they can attain in their core, they actually burn through that fuel much faster. So even though they have more fuel, they're burning through it so much faster that they end up dying well before the low mass stars. Now I think that about covers stellar formation. In the next video, I'll be talking about an interesting quality that we can use about clusters, the main sequence turnoff.